Hi, my name is Jeff Carver from the University of Alabama, and my talk today is on peer code review for scientific software. One of the reasons we want to talk about peer code review is based on some data from a book called Code Complete. And what it shows is the average defect detection rate for lots of different quality assurance activities. So if we look at something like unit testing, we find about a 25% effective rate. If we look at functional testing, 35%. Integration testing, we get up to 45%. But if we look at the average effectiveness of design and code inspections, we get up to 55%. So we see a much greater benefit as we look at these different quality assurance activities. And it's not intended to say that peer code review is automatically better or worse. It's just another tool that we can put in our toolbox. Another piece of data that helps us convince ourselves of this is from JPL that estimated that it saved about $25,000 per inspection because it found and fixed problems early on, rather than waiting till they showed up later in their process. So let me introduce you to a couple of quick concepts here that might help us understand why code review is important. So if we take a look at this code, we'll see a kind of a simple mistake here that somebody used the wrong assignment operator. They put an assignment instead of putting a comparison, which is what was intended. That's going to make this code behave quite poorly. And if we look at another example, we'll see here where there's a redundant check. So the author checked for whether the user is authenticated both outside the if statement and then inside the if statement, they made the same check. And this is problematic because if we decide later that that check is incorrect or needs to be changed, if we forget to update it in both places, we're going to have poor code. Well, the question arises, okay, those are silly mistakes. Don't only novice developers make those mistakes? Well, maybe not. Let's take a look at some examples that we could pull from some open source repositories. In fact, in this case, we see the same exact mistake that I just showed you. We see a test in an if statement, and then we see the same exact redundant test inside the if statement. So this is a mistake that happens in all types of code development. And here's another one that's a little bit different. This one is a buffer overflow. So somebody made a somewhat simple coding error that could result in some significant security problems by not terminating the message buffer the way that they needed to. So these are common problems. They're not made by just novices. In fact, all of us make mistakes. Even quite experienced programmers still do silly things from time to time. I know none of you do, but most of us make silly mistakes. And we're not always able to find our own mistakes, even when it's right in front of our eyes. So it's really helpful sometimes to have somebody else be able to look at our code and be able to identify some of these problems. In fact, I like to make the analogy to writing. Any of us who have ever written a paper know that as soon as we get somebody else to have a look at the paper, they find problems that we may have missed. They find errors. They find things that seemed pretty obvious when you look at them with a clean pair of eyes. And so it's the same idea with code review. We want to be able to say, what are the things that we missed as we wrote our own code that somebody else might be able to find that will help us improve our code practices? And so the question, though, that arises is, okay, that's great, but where does code review fit? I have all these other activities in my process. What gets sacrificed? Is the trade-off worth it? Where do I put it into my process in order to be able to still complete what I need to do in the time that I need to do? So with that as background, what I want to talk to you about a little bit today is a tutorial that we've developed on peer code review. I don't have time to go through the whole tutorial here, so what I'm going to do for the next few slides is just give you a brief overview of the things that we cover in the tutorial. The tutorial itself is quite interactive. I've given it 2 or 3 places, and what it really does is it serves as a starting point for developing a much more detailed discussion with a group or a team about what would work or maybe not work in their particular organization. So what I want to do for the next 4 or 5 minutes is just talk about some of the topics that we cover in the tutorial. I'm going to give you some of the high-level points, but as I said, there's much more discussion that happens throughout the tutorial. So the first place that we want to start when we talk about code reviews is the goal. So why do we even want to think about doing this? What's the point here? And when we think about the goal of code review, we can think about it from a few different perspectives. Only one of those really strongly relates to code quality, but that's an important goal. But if we think about it from 3 perspectives, the first one being a team perspective. So in the tutorial itself, we can discuss this in much more detail, but we can think about what are the team building things that we get from doing code review. We get a better shared understanding of the code base. Maybe we get better team cohesion because we're all working together, looking at each other's code and things like that. There are many other benefits that we can get from team building, and we tease some of those out in the tutorial. Secondly, a goal can be to improve code quality. And that's a really key goal, obviously, that we're doing this whole thing. But things like finding and fixing defects early, like I talked about with the JPL example, getting different perspectives on your code, and even resulting in more consistent code quality and code design. When you have the whole team of people all looking at the same code, people are going to tend to write things in a more consistent way. And not only does that make the code more readable, that makes the code more maintainable down the way when you have to come back and fix it. And the third perspective is personal learning. So as I write the code and I have other people review my code and I review other people's code, it's the same way as when I learn to write. I learn by reading other people's code. I learn by reading good, interesting ways to do things. I also learn by the reviews that I get from other people on my code. And there's other things that I learn personally. So these are some of the three big goals: team building, improved code quality, and personal learning that we talk a lot about during the tutorial itself. But beyond all that, the key goal, though, is that code review is really a peaceful, harmonious process. It's not intended to be antagonistic. And so we want to emphasize that a lot during the tutorial, because if it's not done well, we end up with problems. And so we need to think about how can we do this in such a way that we're all working together for the betterment of the team, and not in a way that we are fighting against each other. So given that, the next thing we spend some time discussing are some of the individual practices. And by that I mean, as the code author or as the code reviewer, what are some of the things that I need to be thinking about so that I go into this process right? Because as I said before, if code review is not done well, it could result in no benefit. In fact, it could even result in negative things if people don't understand how these relationships are supposed to work. We could actually harm the interpersonal communication on our team. So if I think about it from these perspectives, starting with the code author, so if I'm writing the code, I have some questions about, well, what do I need to do to prepare for code review? And there's some things that I need to do specifically in my code to make sure it's ready to be reviewed, and we'll talk a lot more about those in the tutorial. But there's also some personal things that I need to do. I need to realize why code review is happening. I need to realize that the goal of the code review is to improve the code. It's not to attack me as a developer. I'm not my code. So I have to be separate from that. I also have to be humble and realize that I may not have the best solution. There may be other better ways to solve the same problem, and be open to those kind of things. But also, on the other hand, I need to be willing to really fight for something. If I spent a long time, I looked at a lot of different alternatives, and I really think that this is the best solution, I need to pick those battles and decide when it is that's really worth fighting for. We talk a lot more about that based on people's experiences in the tutorial. And then we move on and talk a little bit about the code reviewer themselves. So as the reviewer, what am I supposed to do? How do I make this work well? So we talk about things like what we just talked about with the developer. I need to focus on the code and not the author. I'm critiquing the code. I'm not critiquing the person that wrote the code. So I want to think about what kind of questions might I ask that would help me get into this. I want to think about, maybe I have a way that I would do it, but maybe the way the code author wrote it is just fine. So just like I talked about with the code author, I have to accept that there are different solutions, but I also need to decide, when is it really worth fighting the battle? And I also need to think about, what are some things that I can say positive about the code? We tend to focus only on the negative things, but when you see things that are done really well, take time to praise that, because that'll go a long way towards the team building as well. And again, there's lots more that could be said here, and a lot of these things get dealt with in more detail in the tutorial itself. So then we spend some time talking about different review techniques here. And when we talk about code review techniques, the idea here is we want to determine, what are people good at and what are machines good at? And we want to think about the things that people are good at doing. We want people to do those, and we'll leave the things, the analysis, the static things that the machine is really good at. We'll leave that to the computer because it's going to be more efficient. So I can think about this from two perspectives. I can think about it first from the code perspective. So obviously there's some things that the computer can do really well and really efficiently on checking the quality of the code. But what can people do? So people can check the readability of the code. Is the code readable to a person? Do the variable names make sense? Is there documentation? Things like that. And that's, again, really important for readability, maintainability, and when other people work with the same code. We talk a lot more about some of those things. Secondly, what about algorithms? So there's things that a human can examine in an algorithm because I won't be able to run every test, as I've said before. So are there edge cases that may not work? Is the algorithm implemented right? Are there assumptions? What are some other things about the algorithm that we might be able to look for as a person that would be really, really challenging or difficult to test for? After we get done talking about those things, then we spend a little bit of a time in a code review comment exercise. And the goal here is that we want to think about how as a code reviewer can I write comments that are going to be helpful versus ones that are going to upset the code author and not result in any positive change. And so we have a number of examples that we walk through and talk about the different perspectives and different opinions on how you write code review comments in an effective way. And then we kind of wrap this back around once we talk about some of the outputs and some of the different things that come from code review is, why is this really important for research code, for scientific code? It's useful in the business IT world, it's useful in open source, but what is it about research software and scientific software that make code review a really valuable process? And we talk about things like, many cases the correct results aren't known at the beginning, so writing tests is hard. The complexity of the software make it infeasible to actually test everything. So doing code review may actually help us find problems that we would never test for. And in fact, we have some anecdotal experiences where that's true. So we can focus on testing the science and looking at things that we may not otherwise be able to look at. So this is a really good discussion as people have more and more experience with writing and trying to validate and verify research and scientific code. So that was a really quick run through the type of things that tend to be in the tutorial itself. So what I want to leave you with is, are you interested? If this is a type of tutorial that sounds like might be beneficial to your organization, I'd love to come do it other places. When we're able to travel again, doing it in person is better because we have that interaction. But if that's delayed and something remote seems to be a good idea, we can arrange that as well. But as I said, the goal here is not just to come and have a 2 or 3 hour interactive tutorial to help people understand why is code review good, but the goal here is then to take the next step with individual people or teams to say, well, what is it about your project or your team that we might want to put into the code review process, into a checklist, into a procedure that helps you find the real problems that are showing up in your code. And that's where the real benefit comes, and that's what I'd like to be able to do in addition to giving the tutorial so that we can see the real benefits from it down the way. So if that sounds like there's something that's of interest to you, here's my contact information. You have my white paper. Here's my Twitter account where I tweet about some things related to software engineering and research science. Please follow me there if you're interested. And again, I want to thank the BSSW folks for sponsoring the development of the tutorial and allowing me to be able to do this. So once again, thank you for your time, and I hope that I'll hear from some of you in the future.